Last year, an MIT study looked at 300 enterprise AI projects and found a startling failure rate. 95% of them produced zero measurable impact on the company's bottom line. The models themselves worked perfectly fine in testing. The deployments failed because the companies couldn't get that clean AI to communicate with their messy legacy internal systems. To fix this exact bottleneck, elite labs like Palantir and OpenAI rely on a specific operational playbook executed by a forward-deployed engineer. In this breakdown, we are going to walk through the exact four-step loop these engineers use to build a minimum viable product inside a messy corporate environment and drive actual revenue. Mastering this implementation cycle is the mechanism that produces a measurable return on investment from theoretical software. The process starts in a room with non-technical stakeholders. You'll usually sit down with a client who hands you an incredibly broad request, like asking you to put AI in their factory. This diagram shows how we handle ambiguity using problem decomposition. We start at the top with that vague customer request. Before building a solution, you must interrogate why they want it, filtering out the noise until you isolate one single bottleneck financially worth solving. A common mistake early in a career is taking a vague request and immediately rushing to build a generic toy chatbot. That approach ignores the specific business constraints you were hired to fix. Elite engineering starts by aggressively defining the correct problem, ensuring you don't waste months writing code for a product nobody actually needs. Once you have a sharply defined scope, you transition into building the minimum viable product, usually writing the core logic in Python or TypeScript. In this architecture diagram, the central code block is your clean AI logic. The real challenge is wiring that code into those chaotic, mismatched Postgres databases and legacy APIs. Your code must handle real external authentication and parse authentic, broken corporate datasets. To measure how well your AI processes that messy data, you build an eval harness, a testing framework that grades your output. This harness wraps around the entire workflow, giving you hard, quantitative numbers to prove the system is objectively working. An MVP built in a vacuum has zero value. Its worth is entirely dependent on its ability to survive contact with reality. Next, you have to take that codebase off your local laptop and deploy it into a live Docker container hosted directly on the client's AWS or Google Cloud environment. You're no longer dealing with theoretical code. You are physically on site, debugging live systems side by side with the actual customer. This is where you practice iterating while thinking out loud. By explaining your technical decisions in real time, you demystify the process and build deep empathy with the people whose workflows you are changing. You will also have to politely push back when that customer asks for new technical features that make no sense for their overarching business goals. Deploying enterprise AI is 50% writing syntax and 50% managing human expectations and communicating limitations. A traditional consultant hands over a slide deck of recommendations and then leaves. A forward-deployed engineer writes the code, embeds with the account long-term, and stays until it works. As employees start using the product every day, you monitor the system and refine the codebase to handle all the ugly edge cases that inevitably pop up in daily use. The deployment is complete only when the system hits a measurable business outcome, like a lift in revenue. The FDE takes total ownership of this outcome, measuring success by the final contract renewal rather than technical tickets closed. True job security and high compensation in the AI space come directly from tying your engineering output to measurable corporate revenue. Completing that loop transitions you from a standard software engineer into a high-value implementation specialist. To stand out, execute one step most skip: rigorous documentation. Explicitly outline specific compromises and the exact engineering solutions applied to broken components. Finally, define a clear plan to standardize this bespoke solution, showing how to rapidly deploy it to 10 more customers. Here is your challenge. Pick a messy, real-world industry dataset and run this entire four-step loop to build an elite portfolio project. Executing this real-world playbook is the fastest, most effective way to transform from an AI beginner into an elite builder.